Hello everybody, welcome to my little Twitch stream. Hi, I don't know what that was. My name is Mark Randall. I do developer advocacy for Cloud for Google Cloud I should say, and I work on a project called Agones. We are working on a fun feature today that I'm actually really excited about, that I've been working on for a little bit now. So if you're at all familiar with the project, actually, let's do this. Let's come over here. I'll show you what it is that I'm talking about. So if you're familiar at all with the project, you may be aware, like, we run game servers on top of Kubernetes, and what we do is we have a set of fleets, and fleets are just big numbers of game servers, and then we need to be able to atomically say, okay, I've got 200 game servers, I would like to pick one out of the group and play on that. So you basically what to do, it's called an allocation. Let me see if I can find an example real quick. Guides, here we are, creating a group for game server fleet. And so once you have these big things, basically what we had previously, or we still have, actually, I should say, when you specify an allocation is, this doesn't show it very well, is a much simpler. Actually, let me go over here. Examples, let's say Synodic. Here we go, fleet allocation, right? So usually what would happen is you'd specify the fleet allocation via the name, and you'd be like, that particular fleet, I want to allocate against that one, which is not terrible, but is not actually very flexible, and also not particularly how Kubernetes does things. If you've ever worked with like pods and deployments, usually they have a thing called a selector, which says, you know, hey, give me anything that matches these labels and these values. And so I was sitting down and was thinking about this and thought about how we were doing allocations, and very quickly realized that we should be allocating against a selector for allocations, a selector for game servers, rather than a selector for, rather than specifically games. And that allows us to do a whole bunch of really interesting things. So here's the design that we basically came up with. So here we have it now where we're creating a game server allocation. But here, for example, we have both required. So here we're going to set some match labels. Here's that selector that we can use. So here we're saying this is the label a game server would get for a fleet, so we can match against that. But we can also do preferred ones as well. So if we have to do smoke testing, like we want to test one new version of a server before trying some other things, we can do that as well, which is also really nice. So what's the word I'm looking for? So that means, yeah, so this is cool, and I'm getting there. I'm getting there with it. There's a bunch of other stuff that's just come across from doing allocations, being able to set metadata like labels and annotations on the game servers that comes through. None of that's new. So what I've actually done is we wanted to keep the fleet allocation stuff still working, backwards compatibility. We have some people using this. We didn't want to mess with it too much. So we've got that still going, but we're adding the new functionality. So the stuff that I've basically been doing is I got basically the same functionality as the fleet allocation already working. So that required selector is working quite nicely, which is super nice. What I'm doing at the moment though is we've changed a little bit on how things work. So where's a good example? So here we go. So this is my test. So okay, so the way the flow works, that this probably helps too, is that a fleet allocation is a custom resource definition inside Kubernetes. And what happens is that gets called, and then Kubernetes has this webhook thing called a mutation handler, essentially. So it goes into that mutation handler. Actually, I'll show you. It's probably easier that way. It goes into the mutation handler, and that's able to basically intercept when it gets created, and then we can do stuff to it. And this is basically where we do a lot of our work. So here's our mutation handler. We get a thing called an emission review. That's just what the object's called. It gives us back a big JSON object, so we can create a game server allocation. We can put all the JSON for that object in there, and that's all good. We can basically then do whatever we want. So now we're going to just apply our default values. We're going to go try and allocate. So grab one of the game servers out of the group. And the bit we haven't tested is this bit here, which is whatchamacallit. Okay, no, sorry. If this fails in any way, we can actually set some failure reasons. But if we don't get a game server, if error is right, like there's no ready game servers, we set the status to unallocated. In the previous version, we actually threw an error, and it came back as a 500 on the actual webhook, and it wasn't ideal. It was very hard to determine if something had actually gone horribly, horribly wrong, or if what was the words I was looking for, or if it was just like, hey, I've actually just run out of game servers. I'm sorry. I'm gonna have to work out how to mark this deletion. That's actually a really good question. Yeah, one problem at a time. So when the game server is deleted, okay, then we just set some values on it. Then if it actually works, we set the values on it, like its ports and what game server it's connected to, etc., etc. Then we have to do a bunch of work to create what's called a patch, which is a JSON patch. It's basically a bunch of commands of what to change and what to keep and what not to. And then we attach it and we spit the review out on the other side. That's a lot of work. So the thing I'm writing it right now is we're testing that creation mutation handler. I have some stuff that makes life easy, actually, and we can clean some of this up too. So hold on. Let's go through that. So default fixtures gives me back a fleet, a game server set, which we actually don't need right now, and a game server list. Game server sets, like replica sets, it's the fleet, it's the layers that comes down. So fleets have game server sets, which have game servers attached to them. We create a game server allocation. That's handy. We're gonna set the fleet name label. So we have that's our selector. So sweet. Create ourselves a controller. All right, so here we are doing a lot of the indexing. Now, actually, we can get rid of some of this. So I'm gonna get rid of some of this, and then I'll explain what we've done here. Okay, let's get rid of that because we only need a list of game servers behind the scenes here. We don't need any of this other stuff, and I'll tell you why. All right, so we write a fake controller that gives us access to, here we go. So we have a set of mocks which have a lot of faking libraries in it. I've got a bunch of stuff in here to make my life easy. And we pass in this cube client, this Agones client. They're all mocked libraries, so we can actually look at them. We mock the event recorder as well. So actually, if you want to see, here we go. So the cube fake client sets, Agones fakes. All this fake stuff is either generated for you when you create your CRDs, or available to you in the actual Kubernetes client stuff, which is really nice. Okay, so this is a watch, which is a fake watch, so we can make events happen, and also means that we can populate caches and all sorts of fun stuff. So layers upon layers upon layers. So you'll notice this line here, which says start informers. So if you ever look at the Kubernetes client, you'll see two things. You'll see informers and listers. Basically, the short answer, those things are powered by a eventually consistent cache. It's the short answer. So there's an in-memory cache of all the objects that you're interacting with, and so it can work a lot faster and not have to hit the Kubernetes API all the time, which is a good thing. But we need to get stuff into it so we can do stuff with it. Because if we put stuff in the cache, then everything can react to it and all that good stuff. So there's a couple of things we'll want to do. So the fake client is pretty simple. Like it doesn't do a lot of fun stuff. So to put stuff in the informer cache, one of the things it will do, there's a couple of ways we could do this. One of the things it will do is when it starts up, it'll list all the resources that it can find. So if we tell it what to find, then it'll find them. So here we're saying Agones client, add a reactor, which is a list for game servers. What do I want to return? Yes, true, because I'm good. Here's my game server list. That's the 3 game servers we saw previously. Also, I told you it's not very smart. So we're going to do a patch operation, which is basically like a limited update. We need to tell it what to actually do and what to do with it. It doesn't store state. It doesn't do anything. So we've got the patch coming in for the game server. That gives us a patch object. I'm just going to, for right now, I've got to apply game server patch because there's a lot of JSON in, JSON out type stuff in there. So that applies it and gives us back the changed game server. And you'll notice here I've got like GS Watch is a thing that basically enables you, like the watch fake, to say, hey, like an update happened or a create happened or a delete happened. So you can fake out events. We need to actually do that because when we say like there's a modify that's happened, we want that to happen so that the backing cache gets updated in the same way as it would do normally. And then our other systems can take advantage of that and work as they would do. So basically the thing that I'm testing right now is I wrote a little test function, which I may end up changing, that creates the mission review and runs the creation handler and creates the patch. Like there's a bunch of sort of boilerplate stuff here. And then there's an expected state of what comes through. Now, what was I going to say? So what if I run this, right? So there's 3 game servers, right? I take my game server allocation and I run my test function, so it'll actually do the allocation through the create mutation handler. And then I want it to expecting it should be in an allocated state. What did I just do? And that works pretty well. So if we run this, boop, boop, that'll spin up that, right? And that's all good. We're sweet. So awesome. But what I haven't tested is what happens when it fails, right? So what should happen here is should be unallocated, right? If it comes back on unallocated, then it's going to be unallocated, and there should be one left. So actually, let's leave it the way it was. We'll actually see that test fail. So whoops, I want to run that test again. I apologize for the banging upstairs if you can hear it. Upstairs is moving out. Okay, so it's done what I would actually have expected to do. It has failed. It's failed in a very interesting way, which is in a panic. But on the, where are we? Here we go. Not testing. Where's the actual failure? Package game servers controller test 85. So we break that over. So here it's failed. And then which test? Let's go down deeper. So it's the last one, right? So it has run out, right? That's good. That's what we want to see. That's the good thing. Oh, I see a face in my chat. Excellent. Nice to see you there. So it has failed the way I expected it to. So that's good. So, but the panic is not good. So let's have a look. So if I make it unallocated and we run it again, compiling, bring this back over. Boom. Okay. So should not be empty, but was that. Okay. So in this particular case, all right. So we were doing a little better. If I come in here, it should say, hey, there should be owner references. So owner references are fun. If you haven't looked at Kubernetes, basically it's a way of saying, hey, this object owns another object. And that's useful because when you delete something, it'll follow the chain and delete stuff. So if you create an allocation and then it gets assigned to an actual object, so you actually pull out a game server, we basically attach, we say that game server reference, that game server resource, it owns the allocation. So when the game server goes away, the allocation goes away and everything cleans up nicely and everything's pretty. So sweet. All right. So we've got hard coded here that this should be not empty, and realistically that's not true because in this case it should be empty. How do we want to do that? That's a good question. I could cheat a little and say something like this. It's not cheating. It's all right. If expected state equals boom, else assert empty. I can work with that. I don't think that's unreasonable. Should probably pass it through in some way, but now I can't think of a really good way of doing that off the top of my head. Yeah, I also don't mind. I don't mind. I think that's okay. So let's get rid of that. Let's run those tests. That should now pass, hopefully. Sweet. Awesome. That all sounds really good. All right, so let's run the whole test suite, make sure everything's working the way it would, and we'll move on from there. So this is interesting. I'll actually show you what this is here. You'll notice you get these failed to watch warnings. That's because if you don't put in that fake watch thing, it will complain. It doesn't seem to do anything though. It's fine. It just complains that it can't do it. All right, sweet. That all passes. Excellent. So let's commit that. Cool. Good. Let's go here. Commit another test passing. Yay. All right. Cool. What's the next thing? Okay, so let's bring up our to-do list because I had a bunch here. So allocations, controller. Oh, what's this? All right, write test for all this. All right. So here's a fun one. Actually, this is a fun one. So I actually don't know how we're going to do this or how we're going to test it. It's actually a really good question. So I wonder if we can set the deletion timestamp. Here's an interesting test. Actually, here's an interesting test. So, okay, so the scenario I'm thinking of in my head is, actually, while we're thinking about this, bear with me one sec. I'm just going to start a cluster, minikube, test cluster while that's happening. All right, let me run that in the background. All right, so my thinking is, if we create an allocation and it doesn't find a game server, we want to return a result, but we don't want to keep it around. That kind of doesn't make any sense. So objects have a deletion timestamp. I wonder if we can manually set it, excuse me, and make it go away. That's what I'm wondering. And if we do that, does it just disappear? Maybe? Actually not sure. So we could test this. Maybe we'll do a little test once the cluster comes up, and we will try and manually add the deletion timestamp to a pod or something simple like that and see what happens. That sounds like fun. We can do that. All right. Cool. So while that's going on, why don't we work on preferred? So to go back to what we're talking about here. So this is actually a terrible example because you can't have the same labels with different values. But what we have is, so we have required set, right? This is the game servers we have to have. That's important. But what we're also saying is if there's some that match up to the preferred set, then let's grab out of that set as well. So let's grab those preferred ones. So this is useful if, say, like I said, you have a test server or something like that, or maybe you want to what's the word I'm looking for? You want to maybe allocate it to a certain fleet first before another ones. Maybe there's particular hardware or stuff like that. So this is going to be interesting, actually. So I had it to do here. Here we go. Implement preferred. So I've got this set of code here in find. So this is find ready game server for allocation. And I have a list. So what happens? Okay, so what happens here? We do have a comparator that comes through that's actually really useful. So the comparator, where are we? So we... Let me think this through. This is actually interesting. Counts as node counts. Okay. So what we do... Oh, this is okay. So we pass in an array of game servers, which is good. That's a good start. We pass in a comparator, so basically, so we can do some preferential treatment for it. This basically dictates whether or not we pack allocated game servers together in one big group, or we distribute them out over the load, which most of the time, for a cloud, we group them together. And then we spit back a game server. So what do? We take our counts. We have our allocatable game servers, track potential game servers, one for each node. So we go through, we make sure they're not deleted. If they're either allocated or ready, we put them in the count system. Cool. And then, okay, so we don't have counts, then we create a simple node counts. Here we go. And then we say the number of allocated and number of ready. Boom, off we go. So that's looping through. And then we also have we have a map. We track all the allocatable game servers for each particular location. Okay. Fun. And then check the best node count, and then check the best current game server from the node, most game servers. Okay, so basically we say best count and best, right. And so count.ready is greater than 0. Cool. For the current count. Or if we don't have a best game server yet. We run the comparator function to basically say, hey, where should we go? So the distributed one looks at the ones with the most number of ready and like pack comparator. Here we go. So basically, it's looking for the ones with the most allocated. Otherwise, if allocated, like for tie breaking, then we look for the most ready. That's basically how that works. Distributed comparator is basically the reverse of that. Now, we want to keep doing that for preferred. So I'm wondering actually if we can do this kind of recursively. I keep getting messages. Is it anything important? Probably not. Nope, it's just people in Slack. Cool. All right. Let me think about this. This is the bit we haven't done yet. So my thought is we should be able to reuse this code because what we're doing is saying, hey, how do we do this? All right, let me think about this for a second. Bum, 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 bum. Now that I think about this too, what we're doing is we're actually currently grouping together allocated game server for a particular group, but we aren't keeping together allocated game servers in general, which isn't as good now that I think about it. And that's not ideal now that I also think about it. So I actually want to tear this apart. I want to tear this apart really badly. And what I want to do is have a system that tracks the number of allocated game servers in a particular system, in the system in which nodes they're in, basically, so that we can look for game servers that are already in that nodes or in those nodes. Basically counts. And actually, now that I think about this too, can we make this faster by tracking that data over time? Because what we could do, which is an interesting idea, potentially, actually, maybe not. So, this is interesting and fun. Reason being that, all right, so no, go away. Here we go. So when we allocate, where are we? Where's our allocate function? When we allocate, we lock it, we wait for caching on game server so that we have like a basically as up-to-date as we possibly can version of the cache. And then we get our list. We list basically all the game servers based on the selectors we have for the game server allocation. Depending on which scheduling we have, we pass in the right comparator. We could actually clean that up a little better, which is fine. And then we say find ready game server allocation. Now, the counts are ready and allocated. I am wondering, if I have a system specifically for keeping track of how many allocated game servers are in each node, which would take some of this looping out, which is nice. We can keep the data structure. I don't think that's unreasonable. And we then just thinking through, we then have that as a thing, and can sort. Where are we? Think this through. Okay, so we do this. We track an allocatable game server for each node. That's fine. We can actually keep doing that, and I think that's okay. What I really want is some sort of sorted set for nodes. Would make my life easier. But all right, let's start one place at a time. We have some what's the word I'm looking for? We have some prior art for doing something like this previously. So in game servers, we have a port allocator, which is basically another controller. Inside our controller, we create our port allocator, and I just want to see how I do that. Run verification port allocator. Yeah, I just say run stop. Okay, cool. Run the port allocator. That gets up and running, and we are good to go. All right, so that is, yeah, that's got event handlers, and it's, what does that do? Is that a, where's the blocking function on that? Running, stop, where does stop come from? Wait for cache sync. Huh, do you know something? I don't know if that needs to be in a Go routine. That's an interesting question. Things you find in your code. Run, let's do that. Yeah, I don't think it does. Where are we? GameServer. I'm just write all to do. Whoops. Whoops. What did I just do? Here we go. Things you find. What I really want is actually like a, yeah, I want to like bookmark it, but I can't. All right. To do, where's the things? This is my to-do list. Actually, I've done that. Cool. In game server controller, no longer need port allocator dot run to be in a Go routine. Sweet, nice. Glad I see all that. All right, sorry. If I don't write that down, I'll forget about it, and then I won't come back to it. Okay, so I have some prior art here. So yeah, I think that's going to be a good start. Everything is committed. Yep. All right. So even if I don't like it, I can go back to it. All right. So we're going to call it a allocation counter. Seems reasonable. It's going to need some things. What's it going to need? All right. So what I want it to do is we'll have a, actually, how did I do? It's not a controller. So it's gonna have the same patterns, but all right. So yes, we want to have it's not a controller. It'll be a allocation counter, and that is allocation counter. I don't know if I like that name, but counts how many allocated and ready. Whoop, can't spell. And ready game servers currently exist on each node. This is useful for scheduling allocations on the right nodes. This will actually be a better improvement too. Should be nice. Okay. So what do I actually need out here? I need GameServer synced. That seems reasonable. I will need a GameServer lister. No, I don't need a GameServer. Yes. No, I don't. I just need GameServer allocations. I need a GameServer allocation lister. Allocation. No. Allocation lister. And that's V1 Alpha 1. That seems okay. I think that's actually what I've been doing recently. Or have I? What did I lister V1 Alpha 1? Yeah, that seems reasonable. Let's do that. Import alias. All right. Cool. Stop function, that's great. I don't need a mutex, I don't think, and I don't think I need that. But what I do need, we're gonna pull out some stuff. There's a couple of fun things in here. Okay, no, in find is where it is. I want type node type struct, which will be in here. Yeah, I know, dog. Don't know if you can hear that. She's complaining. What time is it? All right, 34 past. Awesome. So that's our count system. And we'll just call it, actually, I'll tell it at the bottom. Call it counts. And it's a map of string, which is the node name, and node count, which I think is basically what I did here too. Map string pointer to node counts. Okay, that sounds reasonable because we want to be able to change them. Yep, cool. I can work with that. Sweet. I don't know ahead of time. I'm just wondering whether we could also track allocatable game servers for particular positions, but we don't know ahead of time what the scheduling strategy is going to be. So I don't think we have a choice. We have to do this. But one problem at a time. One problem at a time. This means that this actually makes allocation a lot simpler in that we can actually loop through and just look for game servers in the list that we've gotten back on the top nodes, essentially. Yeah. Yeah, I really wish this was a sorted map. If I had some kind of Golang sorted map, this would make my life easier. Golang sorted map. Is that, I don't want to, yeah, I want to do sort map values by keys. No, I actually want to sort key values by map. It's a value sorted map. By key or value, blah, blah, blah. Yeah, I really don't want to be doing that every time. So, this seems getting your same function. How are you sorting? Create an empty sorted map with roughly constant time range, comparison func. What is comparison func to IJ interface? Finds the type of the comparison function with chosen value type. Nah, it seems complicated. All right, one problem at a time. Let's actually just get the counting working, and then we can work out how we want to do this. At least we have the data structure then. And this will also give us better, what's the word I'm looking for? Better performance across the world. So across the whole set of game servers. So this is good. All right. I can steal a bunch of code from here. Where are we? Yeah, let's grab all that. It's not quite what I want, but it's close enough. Inside is it inside the run that I set events up? Oh, you don't actually fire for events. Give me an example in game servers. That's better. Actually, yeah, you're a better example actually too. Blah 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 blah. All right, so we do have informers. All right. There's a bunch of stuff I don't need. Wow, there's a lot of crap in here. I don't need all half this stuff. I'm gonna steal it and then we'll just chop it down. I like to have my things at the top. All right, so this is gonna be a new allocation counter. I know. Hold on. New allocation counter. There's nothing special in that. Webhook, don't need it. Health check, don't need it. Allocation mutex, don't need it. Don't need that. Don't need that. Don't need that. Don't need that. Cube client, definitely don't need that. Informer factory, don't need that. ext client, don't think I need that, but I do need the Agones. Basically, I need the Agones. Oh, I don't need COD getters either. GameServer, actually that should be GameServer allocation synced, which again I can get from the external versions, which is that. Alright, so let's pull out the stuff I need. GameServer. Yeah, let's clear out a bunch of this. Yeah, just copy pasting code around because it makes my life easier. Allocation counter is what we want. All right, so here we go. Because a lot of this stays the same, so it's cool. The sort type isn't string. The sort type would be on the counts. Cyril, you asking that? What's the sort type? It's a good question. I'm thinking that we would sort on. You would keep in the list. The top one would always be the best, essentially. I mean, we could actually just loop over it and find the best one on each event if we wanted to. It's not the end of the world. Like, it's no end operation, so it's not terrible. We could actually do something like best node. No, actually that doesn't work. You don't want the best node because there may not be anything you wanted in an ordered list. Anyway, one problem at a time. Get the thing going. So Agones Informer Factory, cool. Which we want in here to be. Actually, we want the GSA Informer, which would be actually Agones. Let's get rid of that. Actually, Agones Information Factory dot stable dot v1 alpha 1 dot game server allocations dot informer. There we go. I'm just going to strip all of this out actually, just because it'll make my life easier. And logger is there. That's fine. We don't need any of that stuff. And where are we? So logger is going to be done. Game server allocation synced will be GSA informer dot has synced. So that's fine. That's a function that enables us to get like the latest cache version. Game server allocation lister will be GSA informer dot. Oh, have I got the wrong thing? Maybe I have. Oh, I have. Bear with me one sec. So we'll do this. Dot lister, which means then we can actually turn this into a variable. No, I want the whole thing. So allocations. Variable. 2 occurrences. Thank you. GSA. GameServer allocations. I can work with that. Beautiful. IntelliJ refactoring, everyone, for the win. All right. So that gives me that counts. We can do as a, again, it's just a map string node count. Beautiful. And stop is stop, which I don't think we actually care about too much. I'm actually wondering whether we even need a stop. We may not need stop. I don't think we need stop. I don't think that's important. And in fact, looking at this, I don't think this needs to be public either. So let's make it an allocation counter. Yep. Do it. And that also can be private. No one's using it yet. Because nobody else is going to use this thing other than that controller. So probably should be private. Probably fair. And they're all in the same package, so. No, sorry. My brain's not working. Hold on. My brain just fell over. No. We're good. Yeah, it's private to the package. Yes. Oh my god, how did my brain work? How does public reference? How does like public and private working go again? It is package. Yeah, new allocation counter. Okay, it is package scoped. Okay. Everything private is package scoped. Okay, and we just want it to be part of that. I have tended to make everything public. Health.go. Yeah, everything's public generally. I'm gonna just stick to that. I also just like it doesn't. I don't think it has to be hidden. I don't think there's any reason for it to be hidden. People want to pull it out and do stuff with it. I think it only ever drives me nuts as well when people build stuff and then you're like, I just want to extend it and use it, and then you can't because, okay, I don't need any of this stuff. So we do want some event handlers though. I think these are pretty... All right, so here we go. These should be really straightforward though. What time we got? 1:45. Yeah, I'm actually really happy with how I think this is going to work quite nicely, where we track the number of allocated per nodes. Even if it's off like a little bit, I think it's fine. It's eventually consistent. Doesn't have to be absolutely freaking perfect. I think, but it'll mean that we're not taking the entire set of game servers, looping. Yeah, and we'll also be able to pack better because we'll be looking at the full set of game servers. We won't be looking at just the selected set that we're looking at right now, and that'll get us a better packing strategy. And I think that's going to be better. That's going to be better. Yeah, I think that'll be better. Cool. All right. What did I just do? I just did something silly. Cool. Cool beans. We don't need to queue anything because then we have a GSA informer. We don't need to queue anything because that should be allocation controller. Allocation counter. Once we have the information in, they really can't fail. We're just adding and subtracting stuff. Ooh. We need a mutex. We absolutely need a mutex. Because there could be stuff that... Well, here's an interesting question. Do we want to do it with a mutex, or do we want to just put it in channels? Let's do it with a mutex. And we're going to do a read-write mutex. What do we normally call them? Yeah. Count mutex. Yeah, we're gonna need a mutex. Actually, we want to read write mutex. Because events could happen at any point in time. They are asynchronous. All that good stuff. So yes, we are going to need. Can I have a read write mutex, please? Thank you. That is going to be important. All right, so we're going to want to do stuff on add, and we're going to do a thing. Func object interface. Yep, exactly. We're going to want to. It should. What do I normally do there? Actually, it's a really good question. Just real quick. GameServer's controller. Yeah, we just do that. All right, so what I'm thinking is the following. We do something like this. C dot, actually just gonna call it ink because I'm lazy. Should we just, yeah, I'm actually gonna just call it ink. Object dot 2.0 GameServer allocation. 1, so we're just going to increment at 1. I know that doesn't exist. And then delete func will be a function. GSA comma OK equals object. So in theory, this can actually come through as some other stuff. GameServer allocation. If okay, where are we? If okay, right. If it doesn't, because it comes through as like final state unknown thing. So if it doesn't, then we don't care about. But c.inc GSA. All right. So now we just need that function. Create method inc. AC I think is a good way to do that, and we're gonna put it down here. And oh, here's a fun question. Okay, so we're getting. Oh no, the GameServer allocation has this on it, so we're okay. On add, here we go. If GSA. Ooh, do we want to do this here? Ooh. How do we want to do this? Let's turn this into an object. Variable GSA. If GSA dot status dot state equals GameServer allocation state allocated. Right, like only if it's allocated do we want to do it. Same thing here. Okay, and do that. All right, only if it's a valid, right? Like, because if it's not allocated, then we don't care about the count. Like nobody cares. Doesn't matter. How are we doing for time? We're doing okay. I have 3 more minutes. So now we can do a lock. Just c.count. Oh, sorry, AC. What am I calling it? Yeah, AC is fine. Oh, actually, C is fine too. I like AC better. Let's rename that all the way through. We'll call it AC. There we go. So then we're consistent. AC.countMutex.lock, because we're going to be editing stuff. .countMutex.unlock. That should be a defer. All right, sweet. So we're going to increment. So first thing we do is we need to find, well, actually, if, all right, so underscore OK equals AC dot counts, which is, where are we? Where's our allocation? Actually, we tend to call that GSA. So let's stick with that. GSA dot status dot node name. If not okay, then AC.counts GSA.status.node name equals a new node count with 0 values, which is fine. That's easy. Oh, actually, it's a pointer to node count because we're going to change it. Excellent. And then AC.counts.gsa.status. Status dot node name plus equals I. You don't like that? Why don't you like that? Invalid operation. Mismatch types. Node count. Oh. It's odd. I've done the wrong thing. What I actually do need to track is game servers. I don't need to track allocations. Because I want to count both ready and allocated. My fault. All right. I'm going to write some twos. I actually need to run in 1 minute, so I'm going to write the things I actually need to do here. Here we go. I write a thing to do. Instead, actually track game servers rather than allocations, and then base counts off their state. That's what we want instead. That's what we want instead. Yeah, that's not as good. Yeah, because we have to, because node counts are both ready and allocated, and we need those data for doing stuff. All right, I need to run. Oh, my internet dropped out. When did my internet drop out? Bollocks. Why does my Wi-Fi drop out here? That's really annoying. I need to run. Unfortunately, my internet just dropped out. I'll put this up on the recording. And that's annoying. But I need to finish this and I need to run. So I will have to get back to this later, but that's unfortunate. But yeah, I am on. You can see me on Twitch. You can see me here on YouTube. All the good stuff, and I'll continue on from there. So thank you for joining me for this little while. Anyway, thanks so much.